Hey everybody, in this video we are going to begin with the SOHCAHTOA formulas for sine, cosine, and tangent, and then we're going to fiddle around with those formulas to find other formulas which will be useful for finding missing lengths of right triangles. So starting with this first equation here, that the sine of some angle theta is just what we're naming the angle, just like very often we use x to stand for some number. So the sine of some angle theta is equal to the length of the opposite side of some right triangle of which theta is a part, divided by the length of the hypotenuse. All right, now what would happen if we were to just take this equation and multiply both sides by the hypotenuse? So if we multiply by the hypotenuse on this side and then multiply by the hypotenuse on this side, it would cancel over here, and we would be left with, I'm just going to read the right side first, that the opposite side of whatever right triangle we're talking about is equal to the hypotenuse of the right triangle times the sine of angle theta. Okay, so we've got, we fiddled around with this equation and we got a new one. Okay. This is like a recipe for finding the length of the opposite side of some angle in a right triangle. So if we know what the hypotenuse is and we know what the angle is, then just multiplying the hypotenuse by the sine of that angle would give us the length of the opposite side. And we can continue fiddling around with this formula to get the hypotenuse by itself. We could divide both sides by sine theta. Okay, the fact that I'm not writing the parentheses here doesn't mean anything other than I don't want to write the parentheses right now. So these would cancel out. And what we are left with, again, I'm just going to read the right side first, is the hypotenuse is equal, the length of the hypotenuse is equal to the length of the opposite side divided by sine theta. Okay, so we fiddled around a little bit more and we got another equation. That's what I just read to you. The hypotenuse is equal to the opposite side over sine theta. Okay, now what if we fiddled around with this equation over here? Well, if we multiply both sides by the hypotenuse, it's very similar to what we did over here. If we multiply both sides by the hypotenuse, then it would cancel over here, and we would get that the adjacent side is equal to the hypotenuse times cosine theta, right? Multiply both sides by the hypotenuse, and we get that the adjacent side is equal to the hypotenuse times cosine theta, okay? Now, if we want to get the hypotenuse by itself, we could divide both sides by cosine theta. And then we get that the hypotenuse is equal to the adjacent side divided by cosine theta. So that's what I wrote over here. All right, and then finally, we can take the tangent equation and multiply both sides by the adjacent side. So the tangent of some angle theta is equal to the length of the opposite side over the length of the adjacent side. If we multiply both sides of this equation by the length of the adjacent side, then we get that the opposite side is equal to the adjacent side times tangent theta. All right, and again, fiddling, our last fiddle, if we divide both sides here by tangent theta, then we get that the adjacent side is equal to the opposite side divided by tangent theta. Okay, so we started with our original definitions for sine, cosine, and tangent, and what we found were basically recipes for figuring out one of the sides if we have some other information about the triangle. And what I'm going to do for the rest of this video is just take these equations and use them to help us solve some IXL exercises. All right, so let's go ahead and I'm on I don't know if you can see it. I am in Algebra 1, Now let's do Algebra 1, HH4. Trigonometric ratios, find a side length. Okay, here we go. All right, so we have some triangle WUV, and we want to find the length of UW. So we're trying to figure out the length of this side over here. Okay, so what we are going to be doing now is Algebra 1. You can see I'm on Algebra 1. HH4, trigonometric ratios, find a side length. Okay, find XZ. So we have a triangle here, a triangle XZY, and we're going to try to find the length from X to Z. And the information that we're given is that the hypotenuse, I know that this is the hypotenuse because it is across from the right angle. I know that this is the right angle because it has a little square drawn in there. Okay, so this is the hypotenuse. And we also know that this angle is 44 degrees. All right, now the first question that we should ask ourselves is, what's the relationship between this angle and this side over here? Is this side opposite this angle, or is this side adjacent next to this angle? Well, this side over here is adjacent to this angle. It's right next to it, okay? The hypotenuse is also next to it, but the hypotenuse is the hypotenuse. The other side, which is next to it, we call that the adjacent side. So if this is what we're looking for, then this is the equation we're going to want to use, because we know what the hypotenuse is, and we know what this angle over here is. So if we plug that information into this equation, then we'll be able to figure out the length of the adjacent side. So I'm just going to write that equation over here. The length of the adjacent side is equal to the length of the hypotenuse times the cosine of angle theta. All right, so we'll plug in the information that we know. So the angle is 44 degrees. We'll plug that in here. So now we have cosine 44 degrees over here. So the length of the adjacent side is equal to, and we also know the hypotenuse is 10 units long. So we'll plug that in for the hypotenuse here. So to find the adjacent side length, we'll just evaluate this. And yes, we will be using a calculator for this. So I would recommend going to desmos.com/scientific, DESMOS.com/SCIENTIFIC. Okay, that'll bring you here to where I am. We're just going to type in 10 times the cosine of 44 degrees. So 10 times the cosine, let me get rid of this for a second, of 44 degrees. Make sure, whoops, what happened there? So make sure that whatever I just did, you don't do. Okay, cosine of 44 degrees. Make sure that you are on degrees over here and not radians. If you click on this thing, which you shouldn't, so I don't know why I'm showing you this, but if you click on that, then it'll switch over to radians. Radians are just another way that mathematicians measure angles, okay? But we're not using radians right now. We are using degrees. So 10 times the cosine of 44 degrees gives us 7.193, blah, 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 blah. So over here it says to round your answer to the nearest tenth. So let's remind ourselves how to do that. The 10th place is right after the decimal point. So right now, the 1 is in the 10th place. The next digit over is what we're going to use to make our decision about what to do about this number. So if the next digit over is a 0, 1, 2, 3, or 4, then this digit stays the same. If the next digit over is a 5, 6, 7, 8, or 9, then this digit gets bumped up 1. So this is a 9. We will bump this one up 1, so 1 plus 1 is 2. All right, so our final answer rounded to the nearest tenth will be 7.2. Okay, find EF. So let's just draw a line from E to F. This is the angle that we're given. We're also given this 90-degree angle, obviously. This is the hypotenuse because it's right across from the 90-degree angle. All right, again, we want to ask ourselves, what's the relationship between this angle and this side over here? Well, this side is adjacent to this angle. So again, we would be using this formula to figure out the answer to this problem, because this formula is a recipe for finding the adjacent side. But you know what? I'm not going to do that right now because we just did a problem like that. So I'm going to see if I can get a different kind of a problem. Find the measure of B, find the length of BD. Okay, so I'll draw a line from B to D or D to B, doesn't really matter. Okay, so this is the angle that I'm given, okay, aside from the 90-degree angle, which I'm also given. In this case, I do not know what the hypotenuse is, okay? So this is my hypotenuse over here, and this is because it's across from the 90-degree angle. So I know that this is the hypotenuse. And what's the relationship between this angle and this line over here? Well, this line is opposite this angle. So what I'm looking for is the opposite side. Now, if I had been given the length of this hypotenuse, then I would be able to use this equation over here that says that the length of the opposite side is equal to the length of the hypotenuse times the sine of the angle. But I do not know what the length of the hypotenuse is because it didn't tell me that. So let's see if there's another equation that we could use based on what we know. So we do know this angle here, and we also know the length of this side, which is adjacent to this angle. So if I know what the angle is and I know what the adjacent side length is there any equation over here that would give me the length of the opposite side? Yeah, actually we could use this equation. The length of the opposite side is equal to the length of the adjacent side times the tangent of theta. Okay, so let's plug in what we know. You know what? I'm just going to do it instead of writing it over again. I'll do it over here. So we know that the length of the adjacent side is 3. We know that the angle, which we're given, is 63 degrees. So that's what we're going to plug into the calculator. Next one. So 3 times the tangent of 63 degrees is equal to 5.88 blah, blah, blah. If we're rounding to the nearest tenth, that's going to round up to 5.9. Okay, there we go. So let's look at this problem. All right, WX, okay. WX is from here to here. So what is this? This side over here is the hypotenuse. This side is opposite the 90-degree angle. So actually for this problem, they're asking me what the hypotenuse is. Now, what do I know? I know what this angle over here is. So I know what the angle on the right is. I don't know what the angle on the left is. And I also know what this side length is. So now I have to ask myself, what is the relationship between this angle on the right, which I'm given, and this side, which I'm also given? The relationship between this angle and this side is that they're opposite. Okay? This side is opposite this angle. So I'm given the opposite side, and I'm also given the angle. So is there any equation that I can use over here to figure out what the hypotenuse is if I am given the angle and the opposite side? Yes, I can use this equation over here. Okay? So if I plug in the value for the opposite side, then that would be, you know what, I will write it again actually, over here. So the hypotenuse is equal to the length of the opposite side over the sine of the angle. Okay, so I know that the opposite side is 5. Okay, so I'm plugging that in for the numerator. Okay, I know that that should be theta, not 0. So the angle theta is 40 degrees. So I'll put sine 40 degrees over here. So the hypotenuse is equal to 5 over the sine of 40 degrees. All right, so again, we'll just go over to here. All right, we did all the hard part. Now we're just plugging it into the calculator. 5 divided by, what did I say? The sine of 40, was it 40 degrees? Yeah. Okay, so 7.78, blah, blah, blah. Rounded to the nearest tenth, that would be 7.8. Okay, just remind everybody how we did that. Now, if you have to be very careful, because what if they had not given me this angle? What if instead they had said that this angle was 40 degrees? Then the relationship between this angle, which we were given, which we weren't really given, but let's just say that we were given that angle, then the relationship between this angle and this side would be that this side is adjacent to this angle. So if that had been the case, then instead of using this equation, which had the opposite side in it, I would have wanted to use this equation. This equation tells me how to get the hypotenuse if I know what the adjacent side is. Okay, if I know what the adjacent side is, then I would divide it by the cosine of the angle, not the sine of the angle. So you have to be careful here. These equations are not exactly the same. You can't just take what you're given and divide it by the sine of the angle every time and expect to get the right answer. If you were given the adjacent side rather than the opposite side, then you would have to divide by the cosine of the angle. So you have to be careful. All right, but anyway, in this case, we were given the relationship is that they're opposite, so we went through that. Okay, I'm not going to go through that again. The answer was 7.8. All right, so is this problem different from ones that we've done before? Find RS. All right, so actually, this problem is the same as one of the others we've done already. In this case, we look at this angle over here, and then look at the side length which we're given. This side is adjacent to this side. So we know what the adjacent side is, and the question told us to find RS. RS is opposite this angle. So we're given the adjacent angle, we have to find the opposite angle. So the equation that we could use for that problem is this one, which is plug in the adjacent angle, which is 4, and then multiply by the tangent of 66 degrees, and that would tell us what the opposite side length is. We've already done a problem like that, so I'm just going to switch to jump to the next level, see if we get something different. Find RS. What? That's the exact same problem we just had. What? What? All right, let me jump again. That was weird. Okay, find XY. This is, again, exactly the same. So we are given, that's the angle we're given. This side is adjacent to this angle, and we're looking for XY, which is this side, which is opposite this angle. So we're looking for the opposite side. We're given the adjacent side, so we would use that one again. So I don't know if I will get anything different here. Let's see. Okay, so square roots. So let's see how we can do it with a square root. Really, it's the same thing. Okay, so, and again, it's giving me a lot of problems where I know what the side length, the side which is adjacent to this angle. And I'm looking for VW here, which is the opposite side. So again, I would use this equation over here. The only thing that's kind of tricky here is that this is a square root, and so instead of just 10, that we would plug in the square root of 10. But that's not really that tough, okay, because we're going to be using a calculator for this one anyway. So we'll do the square root of 10, so at least just to get some practice using the square root symbol. Do I even know? Okay, so here it is. Square root of, what was it, 10? Okay, times, okay, so this is, what we don't want is, I don't want to write this. Maybe it is good that we did that one. What was it, 49 degrees, right? Okay. So we don't want to do something like this, because you see the tangent 49 degrees is still underneath the radical symbol over here. I don't want that. So I have to figure out some way of, how did you do that? Maybe what we could do is just put the tangent 49 degrees outside like that, and then, okay, multiplied by the square root of 10. So now I definitely have the tangent of 49 outside of this radical. I don't want it underneath the radical with the 10. All right, and that would give me, what's the problem? What is the problem? Okay, so I just clicked on this thing, which told me that I needed to use parentheses around the argument of tangent. Okay, so this is the argument. The argument is 49. Sometimes called the argument. Oops. So I have to put parentheses around there. Now it'll give it me. Okay, so 3 rounded to the nearest 10th. Again, the 6 is in the 10th place. This is a 3. Anything 0, 1, 2, 3, or 4, this is going to stay the same. So rounded to the nearest 10th, I would get 3.6. Okay, I have another one here. All right, I think we'll just do one more. So find the length of GH. In this case, here's what we're looking for. Okay, we're given this angle, and we're given this side over here. All right, this is good because we've done so many examples where we were given a side length which was right next to the angle, and we called that the adjacent side. And technically, this side here is adjacent to this angle. So technically, you could say it is adjacent, but we don't call it the adjacent side. Why? Because this is the hypotenuse. This is opposite this right angle over here. So really we're given the hypotenuse in this problem, and what we're looking for is the adjacent side. So this other side over here, which is also next to the 47-degree angle, that's what we're actually going to call the adjacent side. So we're looking for the adjacent side. We were given the hypotenuse. Which equation should we use? We should use this one over here. Okay, we're looking for the adjacent side. We know what the hypotenuse is, so we can plug the hypotenuse in for here. And the hypotenuse was what again? The hypotenuse was the square root of 61. Okay, we're going to multiply it by the cosine of 47 degrees. Okay, and that's going to tell us what the adjacent side length is over here. All right, so let's just do that. Square root of 61 times cosine of 47 degrees. You know what? So I don't end up with the same problem that I had before. I'm going to type in the cosine of 47 degrees first, and I'm going to remember to put it in parentheses. Okay, did it already. I don't know why I didn't do it before. I'll go back and check. Okay, times the square root of 61. So square root of 61. There. Okay, so 5.3 rounded to the nearest 10th. All right. Yeah, I think this is nothing different, right? This is actually just like the last problem. I'm given the hypotenuse. Okay, it's across from the right angle. I'm looking for the adjacent side. So I would use this equation again. All right, so that's it. I'm going to end the video there and have a great day.